Seasonality can impact your time series model. And in today's video, we're covering everything that you need to know about it. We're going from how to identify seasonality within your data through a few different examples, and then showing you how we could remove it from the specific data set. At the very end, we'll go through all of this with Python code. So a lot to cover. Let me jump into some slides and let's start learning. So let's jump into seasonality. So what exactly is seasonality? Well, seasonality refers to periodic fluctuations or patterns in time series data that occur at regular intervals, typically due to seasonal factors. Here's 3 examples for you guys, right? So retail sales, you'll typically see more retail sales towards the end of the year. This is when you have Black Friday. This is when you have Cyber Monday. You also have a lot of holidays at the end of the year, for example, Christmas, right? So sales tend to peak towards this period of the year. Let's talk about temperature, right? Here in Florida, we get very, very hot summers, right? It's going to be over 90 degrees Fahrenheit. It's very humid here as well. But when we go into our winter months, you'll have maybe a week or two where the temperature is in the 40s, but typically our winter months are anywhere from like 50 to 70 degrees. That's summer for a lot of places, but down here, that is a cold temperature, and we tend to freeze with those. I know we're kind of lucky down here, but regardless, temperature is going to be used a lot in this video. So a very, very basic example of seasonality, because you have the same months that are typically hotter or colder every single year. Additionally, you could take a look at something like tourism, and this could be impacted quite a few different ways. So if you're in a ski resort, right, you're going to have more tourists during the winter months. People want to go snowboarding, and you need to have snow for that, and that's an adventure in itself. But let's say you want to go check out Florida, right? You want to go to the beaches, you want to go to the amusement parks. This typically happens in the spring as well as the summer, right? That's why everyone wants to take their spring break down in Florida, because we have great weather then. But these examples, right, are all based off of a year, but seasonality can also take place in days, weeks, right? And you can think of like amount of cars on the road. People want to commute to their job Monday through Friday, so you'll typically see more cars on the road anywhere from like 7 to 9 a.m. in the morning, and then anywhere from like 4 to 6:30 or 7 o'clock at night. And it can be brutal sometimes with how many cars that are out there. But yeah, so let's jump into our next slide, which is going to be seasonality versus cycle. It's pretty easy to confuse these two. So seasonality refers to regular predictable patterns that occur within fixed intervals. You can think of this typically within one calendar year, right? Daily, weekly, monthly, or yearly. And these are, in our example, and the last one is going to be travel months, or you could think of like temperature, etc., right? Now let's take a look at cycle. So fluctuations that occur over longer irregular periods. So this can either be multiple years or decades. And the easiest way to think of this is like an economic recession. It's not always predictable, economic recession, and sometimes you'll be in this for a decade, or sometimes it'll take a few years. Going back to our temperature example, right? This is a pretty basic plot. I'll actually show you how to plot this in Python in just a few minutes, but you can see that based off of the daily mean temperatures, this was grabbed, I believe, at the Orlando International Airport. And then this is from 2010 all the way through 2024. There's data all the way back to the 1950s. Could have grabbed that. But regardless, I felt like this was a pretty good period to show. And you can see that during the summer months, right, easily the average temperature is over 80, approaches 90. It did pass that in 2024. And then kind of like in the winter, we'll have those occasional days that are under 50 degrees, but typically 50 through 70 is what's kind of normal for us down there. The problem with seasonality, well, the data when you have seasonality is not stationary. That means the data does not have a constant mean and variance, and you need to have stationary data for models, which we're going to run a little bit later in this series. Also, when you have peaks, these can be mistaken for anomalies unless they're properly accounted for in your analysis. There's a lot of other reasons as well, but for this video, I think this serves its purpose. How to detect seasonality? Well, there's quite a few different ways, right? We talked about the eye test a little bit earlier, right? To find repeating patterns. You can also take a look at an ADF test to see if the data is stationary or not. You can take a look at summary statistics by a period, whether it's like a week, month, or quarter. And you can also take a look at ACF and PACF plots. We'll be going over all these in this video, although what I will mention is like things even like ACF and PACF. I have full videos dedicated to that on the channel already, so we're not going to go in full detail on that, but we'll just plot to show you what the kind of the seasonality looks like. How to remove seasonality, right? The easiest way is for differencing, which removes trends from the series. I have the formula down over there, right? Or you could also use a model like Surima. And again, when we're going to talk about specific models, those are going to be in future videos, probably 10 videos longer in this series. We have a ton to cover before we even start with Surima. So that is the introduction to seasonality. We're going to jump into some Python programming right now. So grab a notebook and let's get coding. Let's get started. First thing I should mention is where I am grabbing this data from. So I'm grabbing this from the Florida Climate Center. So first thing I want to do is select the station. Now I'm going to grab data from Orlando, and I'll just go down over here and grab Orlando, which is Orlando International Airport, OIA. And then starting date, I believe when I first started this project, I used the starting date of 2010. So just go over here, scroll down to 2010, and date 2024. And then I just grabbed mean temperature. If you want to switch up this video, grab the min, max. But I used the mean temperature and just click download and you'll get a file. I've already uploaded mine over here and you can see this file name. So 86628 underscore 2010 underscore 1 underscore 1 underscore 2024. Now, unfortunately, we're going to have to clean up the data. It's going to be super simple. But if you do want to learn a little bit about data cleaning, video on the channel. It's actually the most popular video on this channel, surprisingly. I don't think it's our best video, but regardless, that's what YouTube decides to show to people. Okay, let's start by importing in a few libraries. So what we're going to do is import matplotlib.pyplot as PLT. Import pandas as PD. From datetime, import datetime. From stats models.tsa .stat tools import add folder. And lastly, from stats models.graphics.tsa plots import plot ACF plot PACF. That should do. And yeah, let's get started. So first thing we're going to do is set up our data frame. So we're going to say df equals pd.read csv. And then we're going to link over to our data. So I'm just going to copy this path here if you're using Colab, or just link to your file, right? That'll give us our data frame. Now, I learned this the hard way. This data frame this Excel file, unfortunately, has terrible column names. So check this out. If I go to df.columns, look at this. We have white spaces in year, month, day, mean temperature. It annoys me, but we can clean this up pretty easily. So what I'm going to say is df columns equals df columns dot strip, or I should say string and then strip. So strip like that. And now if we go to our columns, look, now we're good. Awesome. But just to show you also, if we go over here to df.head, so df head 10, great. So we have year, month, day, but I want to combine year, month, and day together. So let's do that now. And you can see this is just a 5. Also, we still have some pretty bad data in this data frame. You'll see it in a second. So what I'm going to first do is I'm going to create a date column. So we'll say df date, like that. This is going to be equal to pd.toDateTime. Then df, and inside over here, what we're going to do first is pass our year. So year. Then we're going to pass in our month. So month. And then we're going to pass in our day. So day. And then we're going to put over here errors, course. And the reason why I'm getting there, yeah, these are all capitalized, so I actually fixed that really fast. Year, month, and then day. Yeah, just like that. So capitalize them. you should be good to go. All right. I usually don't put all my columns in capitalization like that. I don't like it, but it is what it is. All right. So what I want to do is look at invalid data. So what we're going to pass over here is two different things. And first we're going to say invalid data. And there's two different ways we could define invalid data. So we're going to say this is everything in our data frame. And we're going to use parentheses, a pipe in this because we're using an OR. And the first thing we're going to look at is df date is null, right? Like we need to have a date associated with this. The second on this is if the temperature is extremely low. Now, Florida does not get super cold. It gets cold in my opinion, but not if you're up north, you're going to laugh at some of the different temperatures what I would consider cold. But Florida does not get negative temperatures. So we'll just put like -10. I got to put 0. We'll just put 0. So anything under 0, right? And also to mention, it does not snow in Florida. So it is very rare for us to have even things in the 20s, the 10s. Like, could happen, but I feel way more confident saying that Florida will not have negative temperatures unless there's an ice age or something like that. So if there's no date, it's invalid. If the mean temperature is under 0, it's invalid. So let's just take a look at this really quick. We'll run that. And then I'll just put invalid data over here just to show you. And you can see, for example, right, 2010, 229, we don't have that date in here. Also 2011 19 has a negative 99.9 temperature. All these are negative 99.9s, so they need to go. And yeah, so we'll remove anything that has a null date value, and then we'll also remove anything that has a mean temperature. Technically, I probably could just have one line that removes literally any temperature under 0, and that would clean up the data. I'll just do both just in case. There's not even a just in case. I could literally just do that. But regardless, I'll still show it to you guys. So what we could do over here is df equals df.dropInA. And you could just say subset equals date. Subset equals date like that. Right? And that would get rid of these that have no values for the dates. And really what you could do next is df equals df. And over here, df mean temp. Didn't mean to have double over there, but we'll say is greater than 0. Right? Easy enough. I could say greater than equal to, but also we're not going to have a 0 temperature. Okay, so our data should be clean now. We shouldn't have any of these values in over here anymore. So what we can do now is literally just plot out our data. You'll see the seasonality associated with it. So I'll just go over here and say plt.figure, set our fig size. So fig size equals, we'll put 10, 5, nothing too crazy. We'll say plt.scatter. And over here, I'll say df of date. And we'll have df mean temp. Set a color. For this one, color equals blue. Label equals mean temp. Fahrenheit. Set your size. We'll say ses equals 10. Otherwise, the graph kind of looks pretty bad. plt.xlabel. We'll pass in our dates. plt.ylabel. Temperature F, then plt title, Orlando, Florida, daily mean temp, and over here. All right, and then we'll do plt.xtext, text not tricks, rotation equals 45, plt.legend, plt.grid, plt.show. Okay. And here's our data. We already showed this one over here. Although looking at my source code over here, I accidentally typed in Celsius for this on the slide. So a little bit of error. Regardless, right, you can see the seasonality on this side of things, right? It gets very warm in the summer, gets cold for a few days every winter. 50 through 60 is nice. Under 50, don't like that. I'd rather it be way over here than down over here. But yeah, regardless, those are the mean temperatures. So now what I wanted to look at also is a specific set of years rather than all of these. You know, we have 2010 through 2024. So we'll take a look at a subset of these, and then we'll identify a seasonality from that, because you might not have 14 years worth of data. So yeah, let's do that. So we'll say look at a subset of data. So what we'll do is df filtered equals data frame over here. And then we're going to have another or. Then we're going to have another parenthesis, but this time we're going to use and we'll put another parenthesis over here. And we're just literally going to filter on the date. So we'll say df date greater than or equal to, and this one will have 2022 0101, and then this time we'll just copy this code, solve our df date, and it needs to be less than 2024. We'll put 1231. Yeah, so this will give us data from 2022, 2023, 2024, which is fine. And yeah, let's take a look first at our ADF. So we'll say ADF test. Now, I'm going to go through these a little bit faster. I will have specific videos on the channel for each of these. So just let you guys know on that. They might not be out by the time this video is out, but I am making the full time series playlist still. So just give it some time. All right, so our ADF test, we'll go ADF test equals ADF. So at fuller, and then we'll say df filtered. I'll go over here. There should be no values with an NA, but we'll just put this over here. Still drop NA necessary. Actually spell df filtered correctly. And let's print out our p-value on this side of things. So we'll print out over here ADF test 1. So p-value. Our p-value is 0.6. So we can interpret this. I'm just going to copy and paste the interpretation because I'm not going to type all this out right now. But anyways, the time series is not stationary. I mean, it's pretty obvious that this is not stationary because of seasonality. We already talked about that on the slides. You can't have seasonality and it be stationary, but regardless, right, here's the if else. So I take a look at 0.05 common metric. If you want to know why, check out my statistics playlist already here on the channel. I built out so many hypothesis testing videos, tons and tons. But regardless, there is that side of things for our ADF. Another way I mentioned that we could take a look at is some summary statistics. So what I want to do now is look at specific seasons. So we'll say summary stats by season. And I'll do that as we'll say DEF get season summer month, right? And we'll say if month in 12, 2, return winter. And then we're going to have an elif. So elif month in 3, 4, 5, return spring. We'll do another elif over here. So, and then we'll have an else at the end. So else return fall. And I know I need to fix this one over here. Man, I can't spell fall. All right, this needs to be summer. Can't spell summer either. And this will be 6, 7. So 6, 7, and 8. Great. And then what we'll do over here is apply the function to create a new column. So we'll say df filtered, let me scroll up a little bit, season like this, goes df filtered, center dates, dt, month, apply, get season, ignore this right now, not the best approach, but regardless, it's fine. And we'll go over here is seasonal stats equals df filtered group by season our mean temp. We'll use a describe, so describe, and they'll give us some stats that we could grab pretty fast, multiple stats, and then we can print out our seasonal stats. And yeah, so you can see our counts are about the same, right? They're going to be a little bit different. The mean temperature in fall is 76, spring 75, makes sense. Our summer is 84, winter is 65. So you can see quite a big difference between summer and winter. Even like a 10-degree difference on average temperatures is still pretty big between our summer, spring, and fall. And then you can see it gives us the minimum 25, 50, 75, as well as the max. So yeah, winter gets 38, which I think is frigid. For some people, that's not. But yeah, and then our max over here is 90 for summer, which I'm perfectly okay with. Okay, and now what I want to do is take a look at plotting a PACF and ACF. Those were the first videos I actually developed for the series, but they won't be first in the playlist. We'll grab those really quick. So we'll say fig axis equals plt.subplots 1, 2, and fig size equals 12.5. Plot ACF df filtered mean temp. Again, there's going to be no NA values, but just in case, drop NA. Ax equals axis 0. And we'll set our lags. Lags equals 30. Right. Axis 0 dot set title ACF. Then we're going to do the same thing all over again for PACF, except this time of axis of 1. So just change these out to 1. Change that to 1. Then put a P over here. Put a P over here. Yeah, this gets in the way sometimes. All right, and then 2 more lines. plt.tight layouts. Then lastly, plt.show. This is it. No errors. And yeah, you can see our autocorrelation function, right, or the plot of this. I also ignore the first one over here, which starts at 0, right? But you can see we have a ton of values outside of our shaded area. On the second one too, our first value is outside, which is common, right? 2, 3, but again, you can see like there's patterns in here. Plus, like even later on, we have some values that are still outside, which tells me that the data is not stationary. ADF told that as well, but you can also apply ACF and PACF. So we still need to transform our data if we wanted to run some models off of it, but yeah, and both of these can show us that pretty quickly. All right, so what I want to do now is actually difference our data. And typically, I'm not going to just difference the data before running some models on it, but I mentioned that specifically, at least in the slides. So I'll show you how we can do this pretty fast. So all you have to do is df filtered, then go over here and say mean temp, and we'll call this difference or diff. And this is going to be equal df filtered And then we'll go over here to mean temp and just say .diff. That's, and yeah, I know we're still getting some errors. It's fine. And yeah, what we'll do now is just literally plot this out and we'll call it a video, right? So we'll say plt.figure. So now what we'll do is just plot out the original versus the one where we difference data. So we'll say plt.figure fig size equals 12.5. Can't type today. We'll do original plot first. So plt.subplot 2, 1, 1. plt.scatter df filtered. And actually, you know what I could do is literally just grab the code from above. Should probably have done that. Just make these changes. A lot of it's going to be the same. All right. Scatter, date, mean temp. And I should just change this to df filtered because that's what we're going to be using. Filtered. That's mean temp. We'll still do color size 10, mean temp. And I should label this as original. Original here. Original. X label, date, temperature. Yeah. Orlando, Florida, mean temp. Then we'll do legend grid. Then I'll literally do the same thing over here. So let's grab that. And this time we'll have 212. And then we'll do mean temp diff on here. Let's change the color to red. And then we'll say difference. And then we have show, but I also want to do the tight layout. So tight layout. And I think we're good. Hopefully no errors. And you can see, right, the seasonality, the pattern, right? Down, up, down, up, down. But now, like, our temperature typically ranges from -10 to 10 with the difference, and it's mostly around 0. So obviously you can still apply the log transform, and that will change our data as well, but that will be in a different video talking about how to make data stationary. But yeah, so that's essentially seasonality, right? We covered a lot in this video. I showed you a little bit of data cleanup, which doesn't really impact this. You can look at it visually, determine if there's seasonality, like right over here. Then you can do ADF, right? Which is a hypothesis testing, and compare your p-value that you get at the end. Again, I typically use 0.05. And you can also take a look at summary statistics, right? In this case, I wanted to look at the temperatures for each season, and they were greatly different, right? If there was no seasonality, they'd be pretty close together. And then lastly, what we did too is take a look at ACF versus PACF, the plots on this side of things, which again show the data is not stationary. And we differenced the data, right? Literally one line of code in pandas, and then just plotted both back to back. So yeah, that is essentially the video. Thanks guys for checking out this video on seasonality. And if you found some value from it, make sure to subscribe to the channel. These videos are for free, and we're uploading anywhere from 2 to 3 every single week. If you want to continue this playlist, I have a few videos that I'm going to link down below that I recommend you watch next. And you can click onto the playlist right over here.